will talk about the effects of both on the surface and acoustic behavior of an endangered population of bottlenose dolphins. I will first talk about the introduction. I will talk about why to do this research. The rapid growth of tourism targeting coastal citizens, so more concern about the potential impact on wild animals. And to the governments, there were creation of legislative and management frameworks aimed at achieving sustainability. And to the research, we knew understanding how bottlenose affects of acoustic ability is important, and a wide range of reaction of dolphins to toll bar have been demonstrated. So, but the aspect of behavior response is still poorly understood. So the purpose of this study was to quantify the effects of tour boats and the research vessel on the communication and surface behavior of bottlenose dolphins. And there were 5 questions about this study. I will talk about them later. Talking about the material and method. The location was in Adaptable Zone, New Zealand, and the means of transport was research vessel. The overall time were from December 2011 to November 2012, and the route covers the entire first area. And we defined that when the member was scattered over less than 1 square kilometers and were hitting in the same generation, we called it a group. This shows the route. And this was the longitude, and this was the latitude. This is the start point. We could see that the route follows the west shore and finally return to the start point. Next, let's use stage approach to quantify the potential impacts of research on dolphins. It was still maintained while dolphin group interact with other boats. They called tour boats, such as recreational vessels. And we defined that when a tour boat was within 200 meters, it's called dolphin boat interaction. And this shows the stage approach. We detected the behavior as set period of time and as typical distance. The data collection and analysis, we got the information about movement patterns and acoustics recording. And finally, we got movement patterns containing group composition, boat presence, general behavior state, group coordination, group speed, group density, and heating change. And the group composition was according to that whether they were called or not. Boat presence containing distance and speed. And we have 6 states of general behavior states. And group speed was compared with the research vessel. And the group density was calculated from group size and group spread area. And the acoustic recording, we have 6 samples. If there were no tour boats, it's called inaudible control sample. And if there were tour boats, we have 5 samples. We define these samples according to the distance away from the dolphin. And they were inaudible before sample, audible before sample, interaction sample. That means the distance within 200 meters. And audible after sample, inaudible after sample. We also got the whistle parameter containing duration of whistle, lower frequency, upper frequency, and peak frequency. We got the whistle rates. We defined the whistle rate as whistles per minute per dolphin. And finally, we did static analysis. We model the data. That means we took all of the conditions into considerations and quantifies the influence. And the models also included interaction terms such as co-presence and tour scenery. And I will talk about results and discussion. I will talk about the movement pattern first. This picture shows the group density of movement patterns. X was the different conditions, and Y was the regression coefficients between group density and these conditions. it shows that whether there were tour boats or research vessels, the group with caps had less density compared to the group without caps did. And this was the coordination. It shows the consistent results with the group density. It also shows that whether there were tour boats or research vessels, groups with caps will have less coordination. And this shows the group speed. We found that tour boats had no significant influence, and the more free upbears result was free upbears influence was caused by research vessels. They all caused the dolphins to decrease their group speed. And this was the heading change. We find that the dolphins will just less change their heading directions as research 200 vessels retreat state. This was the overall arrangement, and this was the having no significant influence, and this shows the positive relationship, and this was the negative relationship. And we got the answer to question 1 about the relation between tour boats cohesions and movement patterns. Next, talk about the acoustic behavior, and it was the whistle rat. We got the tour boats and the research vessel had no significant influence on the groups without caps. However, when there were tour boats present, groups with caps will decrease their whistle rate. Increase. Sorry. And this also shows the whistle rate, and it's only audible samples, and it's concentrated on the tour boat speed and the closest distance of tour boat when approaching. And it shows that the DCA doesn't have significant influence on dolphins. However, when tour boat speed increase, the dolphin without caps will decrease their whistle rate, while the dolphin with caps will increase the whistle rate. And this shows the arrangement. We got a question. Answer to question 2, the relationship between tour boat whistle rate, boat speed, close distance of approach. And I have not enough time, so I just talk about the key points of whistle parameter. We got groups with caps will decrease the duration and with higher frequency when tour boats were audible, and we found the strongest change were caused by tour boats. It got the answer to question 3, the relationship between whistle frequency and duration and vessel noise. And so finally, we know that when there were tour boats, groups with caps will had less density, less coordination, and increased whistle rate, and decrease the duration of whistle and increase the frequency. So about the discussion, we expand this condition. The less group density and less coordination, we expand that the mother calf pairs move away from approaching tour boats, and increase whistle rate. We thought that they try to compensate more masking at high noise level. And the high frequency and short duration, we thought that they try to decrease the spectral overlap with vessel noise and increase signal detectability. And we know both noise has high sound pressure at low frequency. In order to decrease the spectral overlap with vessel noise, we expect that they will trend to upper frequency, but we found group without caps change to lower frequency. So we thought it's needed to clarify the mechanism how vocal animals deal with noise in different situations. And we got answer to question 4 and 5 about the relationship between research vessel, dolphin acoustic, and survival behavior. And we got the group with caps are more sensitive to vessels. Next, we talk about the conclusion. We know that were adaptable sound, and we will dolphin protection zones in double sounds, but they don't take the distance into considerations. But our study shows that noise is an important disturbance to communication. So I think we have the take-home message was that both speed and noise minimization should be included in management measures to mitigate vessel impact. Thank you for listening.
Hello, I'm Chewy. I would like to ask, there are a lot of tables. Can you go back to a page where there is a table? Yeah. I would like to ask, what does the star means? There are stars, right?
They start when they found that the influence was more significant. This was about a coffin toolbox, and this was a toolbox. So it doesn't have the curve, it has the curve. So we found that here and here has more significance. We will make the star.
Okay, so the star means that they have significant data?
Okay. Yes.
Thank you.
I want to ask the regression coefficient. How does that how is it being calculated, and what does it mean when it's higher or lower?
You ask what it mean?
Yes.
I explain it easily. Do you know y equals a multiplies x plus b, and a is the slope. Regression coefficient was the slope. And so if it's on the line, we got the positive relationship. That means if we have two factors A and B, and when A increase, the B will increase.
Your talk is about the noise and dolphins' behavior. I would like to ask that, is there pictures in the paper? Because it's hard for me to imagine how they actually did this research. I think because all of these are figures about the data and something.
Which data?
All of these data and results or something alike. But how did they have pictures how they did this research or in this paper?
So you want to ask about how they get this?
Yes.
All of them.
Or some of them.
It's more complex. So I can understand easily, but I can talk about it more. The group composition was through the visual estimation. Like they have the equipment to take picture, and then they open these pictures and use their eyes to. And the.
You don't need to explain it all. I think that's not the key point. Okay, thank you.
Hi, I want to know that they have enough data for the groups with the calf, because we know that calves are hard to discover.
I just talk about they have the equipment to picture them and through their eyes. I don't think about this question, sorry, but I can just tell you that how they find the calf. And the calf define that when the calf will accompany the mother dolphins, and they were 0.5 lengths of their body compared to the adult. And they have the folds on their bodies. So we detect the cough through these conditions.
I think this study should be, in theory, somehow interesting, but the paper itself, these are on the papers. These are all the figures they have. They have a lot of these figures, so this makes it not that easy to present. Therefore, I think what Roy asked is, if the paper itself, it did not provide any photos. And here, for the whole talk, there is no photos at all. This makes this talk sort of stressful for the audience because there's no image, basically. A lot of text, a lot of tables, a lot of words. So that's very stressful for the audience. So for example, here, if I were you, I would use some cartoons. I think you can easily find cartoons in the PPT, in PowerPoint. I already show you at the beginning of this semester how you can add cartoon easily in PowerPoint. You can look for the instruction slides, my handouts, okay? I would use cartoons to explain this, especially what is group coordination. What is that? Okay, so these can all be easily explained without a lot of words. You can easily explain by showing cartoons. One image worth 1,000 words. Okay, you always need to keep that in mind. And then there are some pronunciation issues which include dolphins and tour boat. You read boat, something like that. Tour boat, whistle, not whistle. Okay, and then here, your order of presentation was you talk about the data first, then you talk about the question. It should be the other way around. You should let us know what is your question. Then you show the data. Then maybe if you have time, you can come back and provide your answer to this question. Otherwise, I was a little bit like, what do you give us a question at the end, especially for the final two questions? It's strange to end your presentation with questions. You should end your presentation with periods, or even, okay, not with questions, okay? And then there is a question where you said, I think it's question 3, where you just ask question, and then these are the conclusions, something like that, right? For this one, for question 3, do you have data for question 3? Yes or no? I mean, in your talk, do you have any figure for question 3? Only this? Which one? This one? Okay, so, and is this the corresponding figure? Is it for question 2 or question 3? This one? Okay, so you see, I already get confused. And because when I was listening to your talk, I got the impression that for question 3, you did not provide data. Do you have data for question 3? No, if this is the case, this should be avoided because scientific English is not storytelling. It is not that you tell a story. It is you present data and tell the audience how the data leads to your conclusion. It is not storytelling, okay? So this should be avoided. Always show data before you reach your conclusion. If you think you don't have time to cover all of them, you don't need to show all of them. But the key point is you need to show data, then your conclusion. Not question and conclusion. This is not okay for scientific presentation. Okay? And here, this is actually a very good guideline for your talk. I think, do you have a purpose statement? Something, somewhere, information, question about this study. Okay, this is good. But then at the conclusion, your conclusion was really was really something like, I don't really need to listening to your talk. I know the conclusion already. This kind of conclusion should be avoided. You should always provide very specific information. That is something new that I learned just from your talk. For things like this, already know this. Everyone knows this. Both speed affects dolphins. Both noise affects dolphin. This doesn't need your talk to tell us. So you need to provide very specific new information, not this kind of common sense. Okay, and there are some other things, but I have some time stress today. I will tell you my other comments when I edit your footage. Okay, these are the bigger things regarding your structure. Okay, thank you, Elma.